So this question is about a cubic function, which we can see here, x to the cube, x to the 3 being the highest power, so it's a cubic. And the first question says show that. So we don't need to prove it, we just need to demonstrate that when f of x is divided by x minus 3, the remainder is 24. Note there are only 2 marks for this, so there shouldn't be a huge amount of work required. If we're thinking about remainder, the thing that comes to mind, perhaps, or should come to mind, is the remainder theorem. And if you remember, the remainder theorem says that if you substitute the value that will make the thing you're trying to divide by equal to 0 into the function, the answer that you get is the remainder. So here we're going to substitute in 3, and if we do that we get 3 cubed plus 2 times 3 squared plus 5 times minus 5 times 3 minus 6, which is 27, plus 18 minus 15 minus 6. If you sort all of that out, you get 24 as requested, as asked for. And then part 2, even fewer marks are available here, but part 2 is the same idea. We've got to show that x minus 2 is a factor. And this is another thing where it's very similar to the remainder theorem. It's a subset of the remainder theorem, if you like. If something's a factor, then when you substitute the number that makes that bracket equal to 0 into the function, then you get 0. So if we write that straight at the top, if x minus 2 is a factor, then f of 2, because 2 is what makes the bracket equal to 0, f of 2 will be equal to 0. So let's try that. So f of 2 is 2 cubed plus 2 times 2 squared minus 5 times 2 minus 6. That's 8 plus 8 minus 10 minus 6, which is 0, and therefore x minus 2 is a factor. Let's write that so we've stated what we've done. There we go. Okay, so hence solve the equation f of x equals 0. And the hence here is talking about the fact that we know that x minus 2 is a factor. If we know it's a factor, then we can use that to help us. And one way in which we can do that is to set out a box, a grid, like we've done in class, where x minus 2, because we know that's a factor, goes down the left hand side, and then in the box we're going to put values that will give us this complete cubic. So we start off, we know that we're going to have x cubed here. Remembering we're timesing together. So what do we have to times x by to get x cubed? The answer is x squared. And if we do that, then this means this box here must be minus 2x squared. I'm going to put a line in for the next set of information. Now if you remember, when we do this strategy, then this box here plus this, whatever we put in here, must add up to the x squared term. We've got minus 2x squared, we want plus 2x squared, so in here is going to be 4x squared. If that's 4x squared, because this number, this x times whatever is here must be equal to 4x squared, that means that this is going to be 4x. If this is 4x, then this is going to be minus 8x. Done another line. Now, same thing again. If we look up at the equation where we're aiming for, this is minus 5x. This number here, or this expression here, plus this expression here has got to be equal to minus 5x. So we want to add a 3x onto that to make that happen. If this is 3x, then this one must be 3. And then that means that's minus 6. And if we look, that means in here, in the main body of the table, if we added everything up, we've got the same as we started with here. There's the minus 6, which has miraculously appeared here. It should have done. If it didn't, we've gone wrong, because we know that x minus 2 is a factor. So x minus 2 divides exactly into our cubic. And this expression here is what we're left with. Therefore, f of x is equal to x minus 2 times by x squared plus 4x plus 3. Where we've got that expression in this bracket. This is a quadratic, which is fairly easily factorised into x plus 3 times x plus 1. We look back at the question, we're trying to solve f of x equals 0. So this expression equals 0 when x is either 2, minus 3 or 1. And that's our final answer.